Hello, my name is Vincent Lau, and this is a project that I did with Stephen Lee. We are both electrical engineering undergrads at UCLA, and this is a project that we did for our senior design course, ECE 113D, in spring 2020. In this video, I'm going to be showing you how our program works and walking through a quick example. So first off, this section here allows the user to change some of the settings. So first, you can select the test image to use, and all of those are located in the test case folder. So you can see here there are a couple of images that we have ready. Next, you can set the flags for whether or not to show figures. So you can do that for two of the submodules, segmentation and recognition. And then you can also set flags for whether or not to show the intermediate data and computations for these two submodules, segmentation and structural analysis. So for now, I'm going to turn them both on just for the purposes of demonstration. So the first part of the program simply just reads in the image, pre-processes it to a 0-1 mapping, and then shows it. Additionally, it also defines the dictionary of the characters that we use. So you can see here, this is what we have. So I'm just going to run the program now. So we can see this is the test image that we're using. It's the Euler equation. And this is just the output of the first part. So now I'm going to run submodule 1, which is the character segmentation. And now you can see here, it printed out all of the individual segmented characters. So this is the original equation in figure 1. You can see all these individual characters here. On the right-hand side in the command window, you can also see the coordinates for each of the characters' boundaries. So the segmentation submodule basically outputs these coordinates along with the images that I just showed. Now I'm going to run the character recognition. So you can see here it's producing the predictions for each individual character. And for each character, it basically develops one of these figures here. So I'm just going to show you, I'll show you this one. So the top left image is the original image that we fed into the recognition submodule. The top right image is the pre-processed image. So you can see we removed the borders and stretched it out so that it's touching the 4 edges. And then finally, the bottom left is the test prediction that's made by the model. So you can see here that it predicts the character is a 0, which would be correct. And on the bottom right, we can see the confidence level for each of the characters. So on the horizontal axis, this is all the characters in the dictionary. So you can see there's about 70-ish characters, and as well as the confidence level for each one. So you can see this first bar is very high confidence, and this is the character 0. So since the confidence is the highest out of all the characters, the model would predict that. And then you can see here it also outputs the predictions for each character. So you can see all of them are correct here. So now I'm going to run the structural analysis. Okay. So in this submodule, it goes through k-means for different values of k. So you can see here it starts with k equals 1, and then moves to k equals 2. And then once this normalized loss meets a particular threshold that we set, then the program will declare that they found the optimal k value. So you can see here it declares the optimal k value is 2. And then it shows what cluster each character is grouped into. So you can see there's cluster 1 and cluster 2. And then based on these clusters, then it will make some prediction on the relationship between each pair of adjacent characters. So here relation 1 is the relationship between the E and the I. Then this relation 2 is the relationship between I and the pi, and so forth. So now I'm going to run the last submodule, lexing and parsing. So you can see here it finally just develops the LaTeX source code corresponding to the image as the final result.